Hello, everyone. Welcome to today's webinar, How AI Extends the Toyota Production System, presented by Drishti. We're really thrilled with the interest in this topic, and we know you're going to get so much from our panelists today. We'll get started in a few minutes, but before we do, just a couple of housekeeping notes. So we are presenting a roundtable format today, so no slides will be used. This webinar will be available on demand after the session at drishti.com. You'll also receive an email with a link to the recording, and we absolutely encourage you to share. We've already received some questions from the audience, and we're inviting you to submit your questions at any time using the Q&A box. We'll answer as many questions as we can at the end, and if we don't get to yours, we will follow up with you after the webinar. To submit a question, select the Q&A button at the bottom of your Zoom window. You'll also see a few poll questions pop up on your screen during the discussion. We'd love for you to respond if you're inclined to do so. At the end of today's webinar, there will be a brief survey. And finally, we are randomly giving away 3 signed copies of the Toyota Way. If your name is mentioned, please message the host with the best address to receive your copy. And with that, I'm going to turn it over to Drishti's founder and CEO and our moderator for the next hour, Dr. Prasad Akella.
Thank you, Erin, and welcome to everybody this morning. If it's as bright as it is here in California, around the country, and people are as warm as we are, I think we're off to a good start. It's my pleasure to invite 2 very distinguished panelists today. I'm going to start with Professor Jeffrey Liker. Jeff is a professor of industrial engineering at Michigan, my alma mater, and the author of a seminal book, The Toyota Way. He is the world's foremost authority on the Toyota production system and has documented this in a number of books. I think I'll admit I still haven't caught up with all the books he's written on the topic. I have a stack of them in my bed and I go through them one after the other. The Toyota Way itself is a very critical book, sort of keystone book, if I can call it that, in that series. Published originally in 2004, it identifies the 14 management principles of TPS as written as an observer. Toyota never really officially articulated its own processes for a long, long time. And most recently, this past December, Jeff wrote the 2nd edition of that book. And I'm looking forward to teasing out the elements of this book, in particular elements like the emergence of AI and its evolving role in the Toyota production system and the impact it can have in the future. And before diving in, a financial disclosure. Excited by what we do. Jeff is today both an investor and an advisor to Drishti. So welcome to the family, Jeff. You've been at this for many, many decades. So tell us what caught your interest in the Toyota production system, first of all, and your journey over the last almost 4 decades. You got to unmute yourself, Jeff.
Sorry about that. I have a bachelor's degree in industrial engineering and a PhD in sociology. And when I came to University of Michigan as an industrial engineering professor, I already had an interest in what's called socio-technical systems, which is how the technical and social systems work together to achieve the organization's purpose. And in a lot of the applications in companies, I was disappointed that socio-technical system really meant a social system intervention only, which was self-directed work groups. And wherever I went and saw socio-technical systems, I saw self-directed work groups. And when I visited Toyota for the first time in 1983, I saw a true socio-technical system for the first time in my life, where there was a definite philosophy of how you organize, the factory, and how you organize people within the factory, and the technology, things like standard work, were then tools used by people in the factory to improve the work continuously. So that's what first got my attention, excited me, and I've never stopped since.
Yeah, no, it's clearly been a very amazing journey, and we'll dig into all of the details of this in a short bit here. It's also a distinct pleasure to invite Raja Shambekar here. Raja is the VP of North American Product Innovation at the Product Innovation Center at Denso, a $50 billion auto tier 1 supplier. and one of the best practitioners of the Toyota production system globally. Raja and I go way back. In 2016, I remember the back end of 2016 getting a call from Raja after I met one of his colleagues, Nakamura-san, and this was at SRI. And Raja was kind enough to fly down and see what I think was a science project. And he was able to see past a science project to what the future could look like, and has played a critical role in the evolution of Drishti's product and even the company as we've grown here. He's been a phenomenal educator and contributor to Drishti, helping us think about TPS in the context of technology, something that Jeff writes about in the chapter on how Toyota adopts technology. And, Raja, curious what your thoughts were that first day we met at SRI, and your thoughts on the journey since.
Yeah, thanks, Prasad. So yeah, first time I still distinctly remember meeting you at the SRI office, and you had a very crude video, but it was a video that showed their concept. So it wasn't just a PowerPoint. I think that was the one that really sold, because you, in my opinion, you had an MVP. You actually had a minimum viable product, so to speak, that showed the concept of thing. And when I saw it, it really struck me, because I'd never ever imagined that something like this could be digitized, that human motion could be digitized. It had not even occurred, even though I was part of the R&D investigation as part of our Silicon Valley office. It just blew me away that something this could even be done. And so that was really the one that changed and convinced me that this is something we need to work together on.
Wonderful, and we really enjoy working together on this. You've taken us a long way, thank you. And so finally, I'm Prasad Akella. I'm the founder and CEO of Drishti, which provides AI and computer vision technologies to lean manufacturers around the globe. And we believe that we are ushering in the fourth era of manufacturing, AI-powered production. So there's craft production, mass production, lean production, and with AI-powered production is what we want to do. So I'm going to actually get into the conversation, get to talk to our panelists here in detail, and essentially focus the conversation on this notion of TPS plus AI, about how the practice of Toyota production system evolves with AI, with the emergence of AI. And it's fantastic to have an industrial and an academic view coming together, even though Jeff is a practitioner as well. And Jeff, you were talking about your first interaction with Toyota in 1983. Mine was in 1995. I was an engineer at GM. We had heard all about what was going on at NUMMI, the transformation of what was arguably the worst producing plant at that point in time in the GM family, and its transformation to the best. And I vividly remember flying down because we were building cobots. And the question was, is there a role for cobots in the Toyota production system? That's the reason I flew down. And I was quite struck by what was going on there. And I remember all the tools coming back to GM. We had a number of our brightest engineers being deployed in NUMMI on rotation basis. But I also felt that back in our own plants, we weren't quite making the headway we probably wanted to make. And as I've talked to more and more customers at Drishti, it's become clear to me that there is Toyota and there is aspiring to be like Toyota. And so my question is, despite Toyota being so transparent about what the process is, the methodology is, the socio-technical philosophy is, why is it that there remains a gap in the market?
Well, first of all, Toyota is also aspiring to be like Toyota. They think they're far from the Toyota way ideal. But you can draw an analogy to, I personally play golf as an amateur. I'm not great at it, but I've been doing it for years. But if I were to see exactly what Tiger Woods did, and he gave me a detailed discussion, which is out there, I could study all I want, and I'm not going to play anywhere to like him. So the only way I can get close to Tiger Woods, if I get motivation and I aspire to be great, is to practice and work on it myself. And that's what Toyota does, is they're constantly practicing, learning, working on it. And it starts with this idea that it's a socio-technical system, that they understand their own principles of things like continuous flow and standard work and total productive maintenance and all the tools of lean, but they see it as part of a whole system. That's why they call it the Toyota production system. And at the center of the system our people continually improving. So in fact, the tools were in large part designed to support people who are continuously improving. For example, visual management, it doesn't matter to computers, but it matters a lot to people. And if we can see and quickly grasp, for example, if we're in standard or out of standard, then we can respond immediately. If we have to read something, that takes time and mental energy. So these are tools that are specifically designed for people to grasp the condition, and then they also develop people in problem solving so that they can continually solve problems and improve towards very challenging objectives.
So this central notion of experimentation of tools for people and tools to enable the problem-solving process sounds so basic.
It's basic. It's not common, but it's basic.
It's exactly, and it's almost self-evident as well, because every self-respecting engineer says, I'm a problem solver. So the question, I guess, is the TPS has been evolving over the last 50 years. And my question to you is, what's changed in the last 17 years that triggered you to go back and write a second edition? What's changed in your own mind and understanding, as well as in the world of TPS?
Well, mostly what changed was in my own mind. TPS goes back to the 1940s, and really the basic concepts haven't changed very much. Just in time, we call it building in quality, but stop, identify problems, solve problems, and built on a foundation of stable operations, which includes standard work. So that hasn't changed. But I placed more emphasis in the new book on scientific thinking, which is a systematic way to move toward a goal. And one of the things that scientists understand is that the world is complicated, and they know that they don't know a lot. So they're willing to start not with a solution, but with a hypothesis. I think this might happen, so I'm going to test it. And that was always true with Toyota, is that they always believed you test at the Gemba, you try things and you learn step by step instead of trying to jump to the conclusion, assuming you know the answer, which, for example, in the case of technology means that you typically start with with often a manual process and perfect it to a certain level. Then you start to introduce technology as needed to solve problems. And it can evolve over quite a long time doing that, as opposed to you buy off the shelf software or robotics and you just start to send it every place, implement as fast as possible. So that scientific thinking, which is takes some patience, it's more slow thinking than fast thinking. That's really at the center now of the Toyota way. And then something like AI and the new technology doesn't change what Toyota is trying to do, but it gives them additional tools for doing it better and faster.
Yep, I remember, Raja, you're taking us through the paces and getting a little frustrated that you guys were taking so long. I don't know if you remember, and you sat me down one day and said, Prasad, I'm draining out the fish tank. You want to tell me what you meant by that?
Yeah, that one. So basically, we had we knew what the issues were that we were facing at the Gemba. We sort of, working with your team at Drishti, we sort of knew what the technology was capable of. So we really need to connect the problem to the technology so that we can quickly start seeing results. The two reasons for really to speed up and to try to do this quickly and work collaborative to make that happen is because we have associates involved in this process. And so it's not just about technology, it is interaction with the associates. And so if we continue to just show that this is possibly what could happen, but they don't see the result, eventually as human beings, we start losing interest. And so it's really important that because associates are a key part of this technology success, that we had to speed up and start showing, even if it's small, we need to show the benefits quickly so that we continue to get their interest and we continue to get their feedback to continue improving the technology. So I think that was where I was really coming from when you brought that up.
Yeah, it was actually eye-opening. We took a page out of your book, and for a while, what you did back then was you brought two associates onto the design team, right? And that was a bit of an eye-opening. We sat back and said, why are they doing that? And it became clear to us that ownership, the idea of the best ideas, the knowledge of the floor was coming off the floor. The associates on the line knew that. And since then, we've encouraged all of our customers to bring the line associates into the conversation sooner rather than later, just to turn that flywheel. So that's fascinating. It's all about culture. It's about people. And I think that's the socio part of the thread, Jeff, that you mention all the time, that I enjoy as well. Every so often you make a cryptic comment and I go back and say, what did he mean by that? And the last one you talked to me about was mechanistic. You said, I think like an engineer, and you upset me at one level, but I think that's the best thing you ever said to me. It's like, you got to think like a person, think about the people. So I'm going to move on to the next part, which is a question for you, Raja. As one of the pioneers of getting AI and IoT onto a plant floor at scale at Denso, you've sort of seen the front lines of all of this. So what got you so passionate about this? How do you get started? And what lessons, most importantly, have you learned that you want to share with this audience? Because many of them are probably on the same journey you are, and I'd love to hear your perspective on that.
Yeah, sure. Let me start with the second question. So why is it's really so everybody, all the companies, all manufacturing companies globally are on this IoT race, and everybody wants to be connected, provide that data, and provide the insights to get that one extra competitive advantage over the others. And everybody's on that race. And so number one is we have to compete with the technology to be able to sustain our competitiveness, number one. But number two is, how do you involve, if you look at it, something that you brought up initially when I met with you, and you had provided that metric, is in spite of such a high level of automation in the United States or Japan, where our headquarters is, there's still a lot of manual operations that continue to happen globally, even in the advanced countries. So how do you involve the associate and technology? How do you marry the two? So actually, there's a quote from MIT that really struck me, right? The quote from MIT is that humans are incredibly smart but slow, and computers are incredibly fast but stupid. So if you marry the two, you get the best combination. That's what Drishti kind of led me to that, because you had a technology, but it would not be successful without using the human. And AI is nothing but AI is only as successful as the data set that you enter. If you have bad data set, the AI is not going to solve your problem. And so really the human element was really important. And so the way we approached it to their first question was, we wanted to get the associates involved to see how they view this technology, because it was the first time where a technology was watching how they perform and provide them instant feedback. No time in the past was that even possible. This was the first time ever that your technology was allowing us to do that. So we really approached it from the associate viewpoint. We value the feedback from our associates at Denso. They are the key points of our final line to the product going to the customer. And so getting their voice and having them successfully utilize the technology is really important. So we really looked at what problems are the associates facing, and therefore, how does your technology solve that? So that's kind of the approach that we took in. And we obviously always start small. We think big, but we start small. And then once we are successful, our motto is to then expand rapidly. Again, it's not something new, but to execute that plan is really where the challenges are. Prasad, you're on mute.
Thank you so much there. I think, Jeff, in your book, you mentioned this notion of IT being a supporting role and not the driving factor. When you hear Raja articulating that, I'm curious what your response is.
Well, I mentioned that often in Toyota, they will, not just with motion technology or manual jobs, but even introduction of robots or advanced systems for flexibly making car bodies, they will, like Raja said, introduce it on a pilot basis, but they will often set up a manual line first. I saw this in an engine plant where they set up a manual line and used gravity only with no electricity to feed parts to people and to orient the parts and to, and then once they had the process refined, they would bring that to the production line, and they use cobots, but the jobs now for the cobots were very simplified and clear and standardized. So it's often the case that Toyota will introduce technology more gradually as they improve processes. So the technology, I view it as supporting the people. So for example, if you have visual management and you can do it better with technology and give better information, that's great. If you can't, then Toyota won't use the technology. It often, a lot of the early technologies for standardized work actually got in the way of visual management. All it was doing was showing the same data you could collect manually, but it didn't involve people on the shop floor, and the engineers used it. So that was often getting in the way rather than helping. So the AI provides a whole different level of providing data that's analyzed, evaluated, and tells you where bottlenecks are, and shows you your work balance chart, which shows how you're working compared to the expected cycle time. So there's a lot of valuable information, but it's only useful from Toyota's point of view if it allows the workers and the work team, which includes a team leader and a group leader, to see what's happening, identify gaps, and then they can respond. And then they could spend, Raja has pointed out to me that they're spending less time collecting data and more time solving problems and thinking creatively. That's the Toyota way of thinking, not replacing workers with technology, replacing thinking with technology. And if Toyota were, for example, if Toyota were to get the impression your technology was just to replace thinking, they would not have adopted it. So that connection is very critical.
Got it. So then the interesting question we often run into with our own other customers, Raja, is this the role of senior management in working with the front line, if you will, to change techniques on the floor, to drive to greater efficiencies. How does that play out at Denso, and what lessons might there be to learn from that?
Yeah, let me add to what Professor Leiker said, which I totally agree with him, is that we don't want the technology to replace the human from a thinking standpoint. We want to augment the associate on the floor, or on whether it's the team leader or the group leader or even the associate on the floor. And so our mindset is exactly what Professor Leiker said, and so that's how we approached it from top management standpoint. Is that the technology cannot be successful if we are just replacing the thinking. We actually want to make the thinking grow to a higher value add thinking. So instead of the team leader just making decisions that are mundane, let's give him a technology that provides him data, that provides him a higher level of decision making. And so the approach was that if this technology can provide that, as you said, Prasad, we eliminate the associate or team leader just collecting information. Collecting information adds no value at all. It is the action that you take from collecting that information that truly drives the value. And so until today, the technology didn't exist on a manual assembly line that would provide a real-time feedback on what is going wrong. As Professor said, you've got bottlenecks, you've got cycle time variances between stations, you've got so many variables that drive the efficiency of a manual assembly line. If all those variables, human cannot physically grasp all those variables at the same time while they're also managing people. Now imagine that all these variables that are important in making the right decision are automated and are accurate. And so the team leader now starts to make decision at a much higher level. And when you start making decision at a higher level in real time, suddenly your productivity and efficiency skyrockets. And I think that is the approach, and that's the value that we saw. And that's why we really wanted to try the technology to see how that pans out, and does it really yield the expectations? Does it really yield the value that we think we can get? And obviously the associates were providing us feedback. And so it was very definitely a closed loop system working with Drishti associates, our management, our engineers.
Yeah, this parallels the thinking. When we raised our Series A, Jason Green, our investor out of Emergence, sort of said, hey, what's your mission statement, guys? And so we went through that journey, and we landed up with empowering humans in an increasingly automated world. And it goes back to that notion that you were talking about. 72% of plant floor work is done by humans. 345 million people around the world work on the floor, and there are 2 million robots. And so that became our parallel sort of mantra here, was how do we make people more efficient? And you said it's never been done before, but in the day-to-day world, it has. You think about spell checkers, you think about Waze, which navigates us. You think about all of these tools that are running in man-machine working together with information for decisions showing up. It just improves all of us quite dramatically. And I totally couldn't agree more with you with that. You know, the other thing I'm also seeing is management with COVID's onset is looking at digitization quite different. I'm curious how Denso is looking at that, and maybe Jeff can give us a sense of what the academic world is seeing as well in terms of the role of COVID and the speed of digitization.
Yeah, COVID was definitely an inflection point in manufacturing globally, not just in the US or North America. If you thought that we were on an upward steep climb, it just multiplied in 10 times the amplitude. So the race for digitalization in manufacturing is at a hyper speed at this point. And therefore, it is really important to evaluate the right technology. There's so many technologies that are coming out to support the need for manufacturing to be digitalized. But it's really important that we evaluate the right technology for the problem that you're trying to solve. Just having the technology is no meaning if it is not really solving the problems that we are seeing. And so COVID has definitely completely changed the landscape of digitalization in manufacturing. The speed is very, very fast. And in therein lies the challenge of are we evaluating the technology for what its benefits are? Or are we just doing the technology because the other guy is doing the technology? So we don't want to be in the race just because 10 other companies are doing it. We want to be in the race to totally improve our competitiveness, but more importantly, always the associates have to come in. It's the people that finally drive success. And so if the technology is adding to the benefit of the people, then that is the way to go.
Yeah, no, it's very fascinating that that's the way this whole thing is playing out. It's the people stupid, right? It's at the end of the day, that's what it is, and that's one of those messages I think I picked up from your book, and you're writing and thinking, whether it's Paul Adler or yourself or John Snook or anybody else. The refrain is very clear. You actually help people do a better job, and the manufacturing system turns out in a better place.
Mm-hmm.
Yeah.
Yeah, so one of the things you mentioned, spell check, which is a good example, and I mentioned I play golf, and now when I go to the driving range, there's cameras that are in dimensions capturing the ball and showing me the flight and the height and the speed, and that's that's not that different than your technology or any AI-based technology, and spell checker does that in a simple way as well, but the spell checker doesn't make anybody a great writer. You're not going to write a great novel because you didn't have spell checker before and now you do. And I discovered that those golf AI programs don't make me a great golfer. So it's always how you use the technology. And Toyota still thinks of themselves as a company that values the craftsman. And the craftsman is always trying to get better at mastering their craft. And they also believe in using all of the 5 senses, and you have senses that the machines don't have. So people are always still at the center. And as Raja was saying, it's easy to kind of get caught up in the technology, like say Zoom meetings, because we need to use them now with COVID. It's not necessarily making meetings more effective or decisions more effective, but after we get vaccinated and we get back to a more normal life, in Toyota's case, they want to get back to the Gemba, but they're gonna find now a better balance, I think, between remote technologies and the Gemba than they had before. But if they simply continue to do what they were doing with COVID, it would not be very effective.
That's a fantastic point. I want to come back to that. Let's hold that thought for a minute. Raja, you were talking about the solving problems and selecting technology. The poll results are fascinating. So it suggests that 70% of folks on the webinar here are looking to solve problems, which is, I think, music to your ears. And it's also interesting and music to your ears probably that they're selecting technologies to solve the problem as opposed to the other way around. So I think this level of recognition that the days of looking for fancy technology just because I want to feel happy about it are long gone. And for people like us, vendors trying to build technology, its message is loud and clear. Solve my problem and I'll work with you. So that's very gratifying to hear. I'm going to continue down this path of people and the role of people in all of this. And I remember, Raja, 3 years ago, we had a conversation where you said something that still sticks with me. We were talking about presenting the right data and the insights to your people. And you said, Prasad, I have 8 industrial engineers you were at that point in time in your career, you were at the Battle Creek plant. We have 8 industrial engineers here working for Bobby Baker. And you said, I want 280 industrial engineers on the plant floor. And I scratched my head. I said, what do you mean by that? And you came back and said, no, I have 280 team leaders. And if every one of them functions like an industrial engineer, making small changes every day continuously, this dramatic transformation. And Jeff, when I read your book, you quote this conversation with John Krafchick, who came up with the idea of lean. And Numi talks to a Toyota exec who says, he asked him, how many industrial engineers do you have? Same question. And he says, I have 2,100 team members, and I have 2,100 industrial engineers. So how do you think about AI and Kaizen, this notion of continuous improvement in this new world? Who wants to take this on?
Well, let me start by saying that the team leader role that Raja was talking about, he said the team leader rather than team member. And the team leader role is a special role that you find at Denso and Toyota that often doesn't exist in other companies. And that's the team leader is a production worker who is trained in higher level problem solving skills, and they have more responsibility for things like preventative maintenance and also responding to an andon when somebody pulls a cord and has a problem. And they spend some of their time online in production and some of their time offline, so they have their hands dirty and they know the jobs and they can follow the standard work. And in fact, the standard work belongs to the work group. They own it. Once the industrial engineer develops the initial standardized work, it's turned over to the work group to refine it and continually improve it. So that existed before any AI. So now with AI, you can feed into that system, that social system, better, faster data that they couldn't have gotten before. And then they say, wow, this is great. You know, I'm doing the same thing I was doing, but I could do it better. And I don't have to spend so much time with a stopwatch, and I have more time available for doing my job and problem solving. So it just helps them do what they're trained to do. If you don't have that system, I would argue that it would be worth investing in it. It'd be worth investing more in developing a work group of team leaders, giving them more responsibility for continuous improvement on the front line, and then using the AI to help them do that. Now, if you give the AI to engineers, they can't do as much more broadly. They can do bigger projects, but they can't do as much as the frontline workers. But you have to have that social system in place.
Raja,
if I can,
yeah.
let me add to that. So, to add a little bit more what Professor Leiker was saying. So, to me, I look at it, the current environment, especially in automotive, it's a very complex environment in manufacturing, extremely complex. There are so many variables, so many challenges on a daily basis. And because it's a global network, there's so many unforeseen challenges that come as well. So first of all, the environment of manufacturing has become complex. The other is that if you look at the industrial engineer, why did we say that we want to have the line leader, the team leader, to be the industrial engineer mindset? And if you think about the old way of industrial engineer, where industrial engineers would go on the line, have a stopwatch, as you said, and they would monitor and do that. Inherently, that drives bias. Inherently, that skews the performance of the people, because as humans, we change most likely our performance or our behavior when we know somebody's watching us and they're physically there with a stopwatch. It invariably puts some impact on the way we behave. So 2 issues. Number one is the complexity, and number 2 is the bias that could skew the data. What if you could provide a tool that would simplify and make the complexity to be more manageable in the fast-paced environment that we are? And number 2 is the associates and the team leaders do what they're normally doing without having to change their behavior because they know somebody's right behind them watching with a stopwatch. And so naturally, we bring up the issues that are being faced on a manual assembly line very naturally, but because they're digitized, they're very accurate. So your technology basically solves both these challenges. Is you see the issues, but you see those issues without the bias that might be there. And so it reflects accurately what the true nature of the problem on the line is. And so by having a technology that provides the data and therefore simplifies the complex environment that the team leader is faced with, or the associate is faced with. Number two, you talked about Kaizen. Kaizen is important. It'll always be there. But Kaizen is no longer sufficient to be competitive. Kaizen is important, but no longer sufficient. You have to have disruptive technology. And what AI does, if done correctly, it really provides insight even to the person who's leading the team into truly making the right decision, because they're not getting data that is skewed or biased. And number two, you get large volume of data. So when you have large volume of data versus just one snapshot of that data, suddenly your decision making is much more accurate and more long-term, more sustainable, right? So I think that's really what drive the benefit and the success of what Drishti is doing.
Yeah, I think Jeff very nicely captures this in his book by saying computers process the information, people do the thinking. And I think what I'm hearing loud and clear from both of you is that there's no eliminating the people from the thinking process, from the problem solving process. It is about actually making them much better. So I think this notion that our colleague Akiharu Engo from Toyota says of TPS plus AI aligns, I think, very clearly with where we're going with all of this, that at least in my mind, AI is only going to help hasten broader deployments of TPS. It's not going to change the tenets. It's just going to enable the different tenets, the 14 principles, in different ways. So I'm going to look at the clock here. I'm going to bring us back in with the final question I have for you, because I really would like to bring the audience into the conversation. You've been on a journey, both of you have been on this journey for several decades now. And as you think about AI, what we've just been talking about, in addition to TPS, what guidance would you have for the audience? What, 3 ideas you might have that they should consider as they enable change in their own companies?
Yeah, I would.
I can get you to kick it off.
Raja,
Sorry, go ahead. Okay, so very quickly, sorry, Professor. So very quickly, I think AI is here to stay, and AI is the future. There is no question about it. So without AI used successfully and in the right way with the right data set is the way of the future. It is something that is almost a necessary factor to be competitive. So I would suggest 3 things to really look at. One is the skill. AI is easy to say, but difficult to understand. So let's make sure that our team understands AI. So skill is really important in understanding that. The second is the speed. If you continue to, as we talked at the first question that you brought up, if you take forever, eventually not only will you lose credibility, but you lose the interest of the entire team. So speed is really important. So skill, number 1, speed, number 2, and security of data. So AI, most of the information that AI processes generally for high value analytics, especially like Drishti, which is video analytics, requires the cloud infrastructure. And so now you are providing a sort of like a YouTube video of your process in the cloud. Your security better be very good, because you are now sharing potentially sensitive information that could be hacked into. So I think that, so there's those 3 S's, I would say: speed, skill, and security. But I have one more S, and that is standardization. You got to standardize it. So as Professor Leiker said in his book, standardization drives efficiency. And so those are the 4 S's I would look at before we get too much into the AI technology to implement it at your location.
Got it. I think there's a 4S, Raja's 4S, that needs to be in your book, the 3rd edition, Jeff.
I know, which is part of Lean. So
yeah, I was playing off of that, but
yeah, but anyway, what I agree with Raja, and about the complexity, about there's technical issues. And that, by the way, we're talking about Drishti technology, motion technology, which is one type of AI. There's lots of types, and I learned a lot about them visiting Raja in Battle Creek, and they all have this similar characteristics. But I would say I would still emphasize the socio-technical nature, and it seems to me that when you involve lean folks or continuous improvement folks, they're focused on the front line at improving flow in the operation and creating things like KPIs and measures for daily management of work groups. So they're doing some things that do engage the workers. And then the IT people are trying to solve the technical problems, like connecting to the web in a reliable way and data security. And they're not really talking to each other all that well. And one of the things that impressed me when I visited Battle Creek, and so what Raja is doing, is that he had on his team that was introducing various AI applications, people from the floor who had been quality managers and working level engineers who also were good with IT. And he engaged workers in the early stages. So they had a cross-functional team, and they're thinking about the social and technical system at the same time. Most companies are not as advanced as Denso in the social system side, and they don't have highly functioning, for example, standardized work that's owned by the work groups. So they have the challenge of changing the social system and evolving it at the same time as they're introducing the technology. And what would normally happen is the technology would be handed to the IT group, and they wouldn't know or care very much about the social system or about lean systems or TPS. So I really see this as a collaborative effort, if you really want to get at the full benefit. And if you're in the process of transforming to something like lean, and you're still in, somewhere on that journey, but you have a long way to go in really engaging the workforce. And that requires top management to have a vision of how the social and technical systems work together, how this technology might help if it enables people. And if they see it as just a tool to get competitive advantage and be disruptive, and they assign it to the IT guys, they won't get this benefit.
Mm-hmm, mm-hmm. Yeah, it's interesting as vendors selling into the space, and I think about skills. I happen to sit in the World Economic Forum panel where we're sorting out how do we think about skills in the digital era. It strikes me that there's three things. One is just the methodology, the fundamentals of TPS, the 14 principles. The second is the technology itself. How does Drishti generate this data? And the third is, how do you interpret the data? How does the team leader or the line associate interpret the data? Since it's quantitative now, we've gone away from 5 data points to 5,000 data points or 50,000 data points. And so the way I think about this is, on the second one, the technology, I think it's like Google search. We've abstracted the tremendous sophistication that Krishnendu and team have put into the product away. It's like Google search, where 100 PhDs have created an amazing search engine, but a 3-year-old can type into it. It's the same thing. The technology should be abstracted away, but what is most important is the interpretation of the data and its use in TPS has to be emphasized. And so that's what we've done. We brought on Susan as a trainer on the team to work with our customers to make this journey possible for them, so that we can help them gain the maximum value from what we do. So I think I see, sitting where I am, having spent 5 years of my life on this, I just see tremendous changes coming forward. And I look forward to more of these conversations with the two of you. Maybe the third edition in a decade or so, Jeff, we'll be talking about this meeting and where we see this going. And I thank you both. But before we go anywhere, we have a whole boatload of questions, is what Erin tells me. So Erin, maybe I can hand the floor to you to get questions that the audience has and bring them into the conversation.
Awesome. Thank you, Prasad. Lots of great questions. The first one is from Yuri, and he asks, is AI substituting Go and C? How do we prevent decisions taken from a desk without actually being at Gemba?
Rajat, I think that's the right one for you.
Sure. Yeah. So COVID definitely put a lot of restriction and constraints on Go and C. So Genchi Genbutsu is our philosophy for TPS. But with COVID, it was not so easy to do. And so that sped up the digitalization. But I want to emphasize that uh, Go and See has not been eliminated. All it does is, if you look at the example I just gave earlier, when you had industrial engineers go and see at the line, they would spend half a day to collect that data. Instead of that, now they still go and see, but they go and see with data in hand. Insights are already with them. They're not going to go and see to collect data. They're going to go and see to see the verification of data they have already collected by Drishti tool in the office, right? So it combines the restrictions that COVID has placed. And now in the future, as we move forward, it actually drives efficiency, because to go and see takes a lot of time. It takes people to go walk and see and come back and forth. It's a waste of time. So what Drishti allows is it provides us the insights and the root causes of the issues we are facing. And so when they do go and see, they're more productive to direct and make the improvements rather than just be there collecting data.
But Jeff, if come back to this notion of scientific thinking, hypothesis testing, right? I mean, scientists would go in with an open mind, and are we biasing that process with the data already being provided, or how does that work now?
I think it could make it less scientific if all your data collection analysis happens in front of a computer screen, and you assume when you go to the line you have all the solutions, and then you just implement them and try to verify that you were right. So that would be the non-scientific approach. The scientific approach would be that you get whatever information you can from the computer, so it focuses your attention on this more specific problem. So I know this is the bottleneck. I've actually zoomed into video when that bottleneck occurred, so I'm watching what happens. So I can get a lot of information that way. In Toyota, they would still then go to the line, and they'd probably do some additional observation. And then the experimenting comes from trying things. Like, I think I have this idea for how to shave 5 seconds off the operation. You still have to test that idea. And you might first test it with a mock-up of some sort before you actually develop the tool. So the experimenting part is where you have to be at the Gemba anyway. And then as you experiment, you learn more about the process.
So I guess the
one thing I'd like to add is that again, in Raja's case, being in Denso, going to the Gemba and going and seeing if you're an engineer is very natural. In other companies, that doesn't happen as easily. So you might, there's a concern maybe the technology will reduce going to the Gemba, but maybe people weren't going to the Gemba anyway very much, or as much as they should. So that has to be emphasized in addition to the technology. This doesn't substitute for going to the Gemba, it just gives you more information. So when you go, you can more quickly get to creative improvement.
Correct. This is no different than you have to continue playing golf. It's just the feedback you're getting is how do you play golf better, right?
Right, exactly.
Yeah. So I guess what this also means is that the speed at which you can iterate, you can experiment, probably is hastened, which means you can be turning more turns on things and really be doing continuous improvement, as opposed to once a quarter trying to do something.
Right.
Yeah. Good. Aaron, what's the next question that the audience has?
Great. So the next one is from Ariel, and he's looking for you to define the characteristics that are being monitored in assembly processes and define the boundary limits.
Yeah, so so we define those as key process indicators, or KPIs, that we look at. And for each process, it may be a little bit different. But basically, the basic concepts that already Professor Leiker had explained in his book is, basic concepts of manual assembly line is you want to be highly productive. And so for that, you need to eliminate the bottlenecks. For that, you need to eliminate cycle time variances. For that, you need to eliminate defects that get passed to the next station. It should be always defect at that station and corrected. So these are all basic tenets of TPS. And basically what Drishti allows us, and also the other one would be a pace setter. So every station has a standard work, as Prasad said, and it has a standard cycle time. And so are you achieving the standard work in the given time that you have? So these KPIs have not changed, as Professor mentioned, from 50 years ago. They're the same. What Drishti allows is to provide it in real time with a huge amount of database. So instead of just monitoring 300 cycles in a day, we now have data that has 10,000 cycles. So you look at the normal distribution, the accuracy of that data is so strong because it truly then defines what the bottleneck is. It truly defines cycle variance each station. So KPIs are not much different. It is the way they are collected and how we take action towards them.
Yeah, I would just add to that that an input into the Drishti technology is the standard work, is the steps, and then the technology can show you how much time you're spending at each step. So if you aren't doing a good job of developing and updating standard work, then you have garbage into the system.
Yeah, one other quick comment, if I can add also, it's a motivation. So as professor said, if you have standard work being monitored and that technology tells you as an associate that you are following standard work every time, it's a motivator for me if I'm on the line in the station, right? So.
Yeah, it's interesting, this notion of motivating the line associate. You've told us a number of cases where the OEM reports as a defective unit, but the line associate says, I'm doing the best job I can. I have pride in my job, and then they want to prove that they've done a good job. That's the nature of all of us. We want to do the best, and to have evidence to support that is so critical. What's next, Erin?
Yeah, next question is from VJ. Are there examples of video analytics that improve the safety of the associates?
Yeah, absolutely. That's a really good question. So we monitor our RSI, or repetitive strain injury. Obviously, our associate health is the number one concern above everything else. And so what we noticed, actually one example I can give you is the reach that the associate had was causing non-standard work and also not achieving cycle time. Now, the industrial engineer, as good as they are, they simulate it. And once it is launched, they need a lot of time at the Gemba, as we talked about earlier, to really identify these small nuances that start creeping up as the line starts to mature. And so by having Drishti, the safety engineer was able to look at this and say, wait a minute, the reason that they're not meeting their cycle time and not meeting standard work all the time for this station is look at the reach. And so they started to monitor that across different shifts and very quickly realized that this is not just related to that person. It is an issue that's across shifts and across people. So obviously it's a common denominator, and it's causing, stretching of the arm or raising your arm at a level that could cause repetitive strain injury. And so we were able to identify that, change the line setup very quickly, and actually eliminate that issue. So this is one example.
Yeah, and Prasad, my understanding is that you're including some ergonomic evaluation like that into the software for future releases.
That's absolutely correct, Jeff. We've mocked up an ergonomics product with NIOSH feedback and all of the learnings that have come out of the labs over all of these 30, 40 years. I think that's on the horizon, and we're looking for good partners. Maybe there's somebody in the audience whose company would like to work with us on that, and absolutely the case. In fact, to continue Raja's example, one of our auto OEM customers had an incident on the plant floor, and they were, this associate put her hand in, she was trying to grab a part, was a little too late, had her hand wedged between the engine going down the line and componentry on the line itself. And so they went back and they were able to instantly evaluate what happened, which meant they could treat her and take care of her well. But B, to your point, Raja, they realized it was a systemic problem. They had to solve this not just for her, they had to solve it for everybody else. And the light bulb went off in their minds. Wait a second, you've only been talking to me about productivity and all of this kind of stuff. You just did not talk to me about the human, the safety of the human being. And that's been on our minds. It's in our patent portfolio, but we got to get to it. And Jeff, we will absolutely do that. Erin, next question.
Yes, so the next question comes from Raj, and he asks, Jeff, can you elaborate with an example of how Toyota is using AI tools to supplement their decisions? He says that the big three automakers have been great in terms of IT systems and were actually way ahead of Toyota over the last 3 decades. So you can potentially give examples for Raj?
I think the question, what the questioner is suggesting, that Toyota is not always at the head of the pack in adopting new technology is correct. So Denso, for this particular technology, Denso is kind of ahead of Toyota, and part of Toyota's interest came because of what they saw happening at Denso, and they're probably going to be slower and more gradual. but they are using the Drishti technology at a number of their plants. They would probably say they're still evaluating it. They like everything they've seen so far. And it seems likely that it will get adopted and distributed across the world. The way they tend to do things is more plant by plant, and the plant has to raise their hand and say, we're ready, we want this. So it'll be more gradual than it will be in some other companies. What I've observed is that what Toyota does particularly well is use the technology very effectively and gets often incredible results. Whereas some of their competitors have been really good at deploying the technology, but not getting a lot of benefit from it.
Yeah, Raja, maybe two questions to you. Just following up on Professor Leiker's comment there. Number one, how do you think about the value creation process and the measurement of that? That's the first question. The second, I know that since we started working together, you and Engo-san have had a number of conversations. So this question of how does Toyota learn from its Keiretsu, Denso being a part of the Keiretsu, and how does that propagate through the whole Toyota family, may be relevant to Raja's question.
Yeah, I would say to add to what Professor said very quickly, it's the execution that is important. So although there might be other competitors, OEMs, that are very good at introducing the technology, the execution of that technology and therefore the value that they get out is really what makes a difference. And we work with actually not just with Toyota, but we work with all our customers. Our value for Denso is to enhance our customer through the product quality that we provide. That is really what they see. And so obviously cost competitiveness is to everybody, but adding that value and adding that extra benefit is really important. And so it's not just with Toyota, but we work with all our customers, and we really look at how to use this technology to provide feedback to the product design. That's one of the areas we have not approached. It actually provides us feedback on product design as well as on the quality side. So we work on both sides.
Thank you. Thank you. Erin, what's next?
Yeah, the next question, there's actually multiple questions coming in asking about privacy issues, Big Brother, unions. Do you want to just field that very quickly, Prasad?
Yeah. So I think there's a very fair question as we go into Europe and look at GDPR, we look at PII. We've been in conversation with senior executives at the AFL-CIO. And the union in general is used to technologies replacing people. But when we show up and had the conversation with them about actually augmenting their members, it leads to a different direction. And it's our intent to work with them on a plant in North America so that they get their own hands on the technology and have an understanding. And it's the same thing in Europe. We are working with one of our customers right now to ensure that we are GDPR compliant, and so we can roll this out more broadly. All of that said, I think there's always a give and take in society. I remember when we started Spoke, we sort of were mining people's email to see who knows who, and people were concerned about privacy. And what happens is that you realize there's a give and a take. And the give here is, yes, we've been doing this for 50 years. There's poka-yoke systems, there's measurement systems on a production line. They've been around for a while. They'll be there forever because that's the fundamental nature of manufacturing. But what's different about this is that we're able to take care of the other aspects of it, which is take the grunt work off the person's back, whether it's the team leader or the line associate. It's about giving them data that actually is accurate, to your point, Raja, at the point of decision. And most importantly, there's an element of elevating the playing field so that you actually almost push back on the onset of robots. So there's about protecting jobs because you're doing such a better job that most manufacturers want flexibility. And if you can give them flexible systems that perform well, why use robots, right? So that's part of the conversation I have with executives when I talk to them. And Raja, you might have any comments on that.
Yeah, I would just add one comment. Totally agree with what he said. One comment is that we don't record sound. So conversations are not recorded. So that's one of the things that we don't allow. But if you look at any modern factory, every modern factory has security cameras everywhere. There is no factory that I know modern fact that doesn't have cameras. So watching people is not new. It's allowed. It's already done in almost every country that has a modern factory. It is how we use that technology and how we augment the employment is really what drives the conversation, as you said.
Yeah, I remember the first HR audit I went to early days, 4 years ago. I had that exact same conversation. The HR person came along and said, what do you think about this? I said, look up. the person looked up and said, how many cameras are you counting? And he counted the cameras and said, what more can I tell you? And he looked and laughed and said, okay, approved. So you're absolutely correct.
And also, Prasad, you had mentioned that if a company has an adversarial relationship with a worker, so you can imagine I set up this whole system and it's showing me every time I'm over the cycle time. If the result of that is the supervisor comes over and yells at me, you're going to destroy all the benefits of the technology. And you said that there have been companies you've walked away from and said you're not really a good candidate for this technology.
No, absolutely. I think that's a belief structure within the company. The example I think of is the NFL quarterback. The NFL quarterback throws the interception, goes to the sideline, looks at the video replay. And the whole intent is, I want to do a better job because I want to win the game. It's the same thing with everybody from the line associate to the CEO. You want to win the game. And it's about understanding this technology in that context. And if that relationship is not there, it'll never work. So that's one of the things we test for early in the day. So Erin, I think it's 10 o'clock. It's been a wonderful hour. I've enjoyed the conversation with both of you, the audience as well. Fantastic questions. We will ensure that we answer most of these questions offline. And thank you for spending the hour with us. Hopefully you got some insights from the world authorities in this topic and some tips on what to consider as you roll this technology or other technologies like AI technologies out in your plan. So we wish you the very best as you do that. And thank you, Professor Leiker, and thank you, Raja Shimbaker, for joining us this morning.
Thank you.
Yeah, thank you. Thanks, Prasad. Thanks, Erin.
And everybody stay healthy and safe, most important in this current era. Take care. Bye-bye.
Okay, thank you. Bye.